Hi, my name is Kevin Hirn, and I'm a debate coach at the University of Michigan. Today I'm going to be discussing a pretty crucial component of the topic, climate and environment impacts. And the water topic really is an environment topic. So if you haven't seen either Eric Forsland's optional warming lecture from Saturday night or Ben Stavical's lecture on the water energy nexus, I'd highly recommend you do so, and this will complement those efforts and seek to inform how you maximize the strategic benefits of environment impacts in debate. Okay, so getting started with some general advice. I think one of the big things that would improve environment impact debating across the board is a willingness to learn and defend the scientific backing behind your impacts. A lot of times in debate, I've seen appeals to authority, like this is true because my evidence says it's true. I don't need to explain why because I'm not a scientist. And that kind of thing not only is unpersuasive, but it sets yourself up for failure. You can win a lot more debates if you understand and persuasively explain to a neutral audience and a skeptical audience why your impact is true. And so a lot of the information I'm going to be giving you tonight will be targeted in that capacity. And then two other pieces of advice, and these I think are the two biggest problems with most environment impacts as they're set up now. The first is think about how or why a given impact causes extinction. A lot of times, environment impact cards use very vague language, talk about survival at best. But it's not clear exactly how or why everybody, or even like a large amount of people, would actually die as a result of a given impact. And then finally, think about how or why a given proposal could actually solve globally. Unfortunately, the topic restricts the Ask's immediate action to happening in the US. A lot of environment impacts, most notably global warming and climate change, are, I think it's right there in the name, global. And so if it's not, if it's just domestic action, how can it affect something that has many causes far, far, far beyond the scope of what the app does? And that's true for DA internal link stems and stuff like that as well. So try to think about that when both debating against and constructing environment impacts. It sounds obvious, but based on the impacts you'll encounter this year, it isn't as obvious as it might seem. So the first part of this lecture is going to deal with climate change. So we need just some essential background here, and this is at times a little redundant with Eric Forsland's lecture, although he goes into greater depth on a few areas, especially feedbacks and the greenhouse effect proper. I'm going to focus on some core data and how we know it and how you can defend that it's accurate. So first, how do we know the Earth is warming? Well, pretty much every study, and here's a graph that amalgamates a wide variety of them, of temperature data over the last 120 plus years demonstrates that the Earth is warming. It's warmed by close to a degree Celsius. We know this in a few ways. First, surface evidence. So beginning in the mid-1800s, there's been temperature measurements at weather stations and ships. Later, scientists began tracking those with satellite temperatures. We also have a few long-term sources as well. Probably the most important individually, especially as it tracks both temperature and carbon, is ice core data. And so ice core data comes from little bubbles or pockets of air that are trapped far underneath the ice in glaciers, especially in the Arctic region and Antarctica. And those little air bubbles preserve the atmosphere exactly as it was, both in terms of its temperature and its carbon dioxide content long, long ago. And based on how low it is, we can actually use geological techniques to figure out exactly when they were from. And if we get a whole swath of them from a ton of different regions, we can actually get a statistically significant average, which is pretty awesome. Tree rings, which contract or expand based on temperature, also are useful. And we can look at old trees, old wood, and figure out exactly how hot or cold it was in the recent past as well. And like I alluded to earlier, we even have satellite temperatures now, which are especially nice because one of the problem with surface temperatures is that they can be a little bit biased based on location. So there's something famously called the urban heat island effect, which is that temperatures taken in cities trend warmer than temperatures taken elsewhere, mainly because if you think about it, a city is a hotbed of activity, light pollution, etc. And so there's kind of things that bias the temperature readings, but satellites take that out of the picture and can demonstrate even recent warming rates as well. So we have a bunch of sources for how we know the Earth is warming. How do we know that warming is anthropogenic? Well, it is pretty easy to take a look at the graph, which measures carbon dioxide along global temperature averages and decide for yourself. Both the more recent graph, which is here, kind of has a best fit line that shows since 1880 a pretty unmistakable correlation between global temperature and CO2. But even more damning, I think, is the long-term graph that shows, looking back at hundreds of thousands of years before the present, a very, very, very tight correlation between carbon dioxide and temperature. And this explanation makes sense. It's basically what we'd expect based on our best understandings of physics. The greenhouse effect, which basically is the process through which the amount of sunlight retained on the planet changes over time, is basically the explanation for this. As the sun's radiation and its kind of light travels towards the Earth, a lot of it is absorbed by gases in the atmosphere, and certain gases retain more of it, and we call those greenhouse gases: carbon dioxide, methane, water vapor, etc. And based on how much of that is retained, the Earth will kind of get cooler or hotter accordingly. Now, not all sunlight is absorbed by greenhouse gases. A lot of it's going to get absorbed by the oceans. It'll be used it'll warm the air. It'll warm the ground. It'll be used by plants for photosynthesis. A lot of it will reflect based on, especially the albedo, or that basically just means lightness, like based on how wide or bright the surface is. A lot of it will get bounced back into space. But greenhouse gases retain and trap a lot of it. And two kind of additional smoking guns for this case is, the first is that nights are warming faster than days, which is because greenhouse gases don't go away when sun sets. And then upper layers of the atmosphere have actually cooled because more energy is being trapped by greenhouse gases in the lower atmosphere. So this is a pretty persuasive case. There are still some holes to poke in it, but there really isn't a very strong alternative explanation. Two of the more common ones are solar and volcanic activity. And solar activity is an interesting one because we actually know quite a bit about sun cycles. The sun will put out more or less emissions of its solar radiation. A lot of times it's called sunspots over the course of its life cycle. And it tends to change in 11-year cycles. And between 1880 and 1950, about 10% of warming probably was due to increased solar activity. But this is a major cause for warming is a pretty weak explanation because solar activity has actually been declining since then. Okay, and then volcanoes is another one that, volcanoes do have a huge effect on the global climate, and about probably 1 to 2% total of carbon emissions over the last 200 years have come from volcanoes, especially two mega eruptions, Krakatoa in the 1880s and Mount St. Helens, more recently in Washington State in the 80s. But volcanoes also kind of have a cooling effect because they release a bunch of black carbon and soot. A lot of that will actually it has kind of a cooling effect because it'll prevent the Earth from accessing all of the sun's rays. And so that kind of counteracts even the carbon emissions that it puts out. And like we just kind of stated, the carbon emissions have not been nearly enough to really make a major dent in warming. So now that we're hopefully persuaded by the background of why warming is anthropogenic and real and how we know that, let's try to look at some of the causes of the emissions responsible. In the US, the electricity and heat sectors are primarily responsible, although transportation is a close second. It'll be easiest to affect on this topic, the electricity and heat, agriculture, industry, and waste sections of this, which altogether are significant, but certainly not everything. Electricity and heat produce so much because a lot of the fossil fuels, the core energies that power much of modern electricity production, so named because they tend to derive from carbon-dense fossils, liquefied fossils that have amalgamated over the course of millions of years. And they become so compressed, all of these kind of old organic materials and fossils, that they form very, very useful energy blocks. That's what literally oil, natural gas, and coal are. And so we literally burn that carbon-dense material, and the emissions go up into the atmosphere as a result. We burn it in order to spin turbines that produce steam that heats water, and that's kind of the catalyst for electricity production. So we haven't really talked a ton about different greenhouse gases. Methane is probably the most important one besides carbon, which is so important that a lot of times when we talk about warming as anthropogenic, the card will actually just be about carbon. But methane is significant. If you look at the kind of most recent amount of various gases released, methane is only 16%, and carbon dioxide is 76%. But methane is about 80% more effective in trapping heat than CO2. So of that 16%, it's more effective in terms of part per million in trapping heat. And it's both kind of there's a positive and a negative to its lifespan. Methane lasts in the atmosphere way, way, way shorter than carbon dioxide does. And so that does mean that when we put carbon in the air, we have a long-term effect. But it also means that if we stopped emitting methane, we'd have an immediate impact versus kind of the carbon that's already there lingering for a long time. And so not only would it be kind of meaningful, we could probably reduce overall emissions by 30% if we had a quick reduction in methane, and that might be a little bit more politically feasible. And given that a lot of it is produced by agriculture and energy almost exclusively, methane kind of targets areas of the water topic that are a lot easier to solve. And so methane, I think, will be a very major player in this year's topic. And there is some kind of back and forth over its utility overall in combating emissions. Okay, now in terms of solving warming, it's kind of difficult to do so. So as we'll get to a slide in a second that shows the U.S. is really not responsible for the majority of global emissions, at least future emissions especially. The way to get around this is, in the eye of the beholder, but there are a few different ways to design warming advantages that actually make sense and have a coherent solvency story. The first is that you have a U.S.-specific impact. Now, this kind of maybe goes against the grain a little bit in the sense that you might not even say you solve overall warming, but you solve a contributing factor to an environmental harm in the U.S. associated with warming. And as a result, you could maybe protect U.S. agriculture from kind of worst-case climate effects, or you can prevent maybe a bunch of greenhouse gases emerging around the Yellowstone supervolcano, which would amplify the risk of it erupting and cause a extinction level event. There is some evidence for that, although it's pretty weak in terms of qualification, but it does exist. Two really common solvency mechanisms you're going to hear about a lot are either small amounts of mitigation are key, or small amounts of change by the U.S. are key. So as another slide kind of alluded to earlier, a lot of times when people talk about trying to prevent warming, they assume that some degree of warming is already going to happen, is going to happen inevitably. Some already has happened. But that if we avoid, say, a 2 degree or a 4 degree threshold, we can prevent feedback loops from being initiated that basically take warming and spiral it out of control. And so if we can avoid maybe the worst case scenarios for warming, then it only takes small mitigation to do so. And furthermore, maybe it only takes small mitigation from the US because other countries are acting on climate now, but a failure to reduce our emissions would derail global targets. So those are feasible. There's also modeling and international spillover type scenarios. And so you can do this one of two ways. I think the gold standard for being able to solve warming globally is if you had some type of technological innovation that it was cost efficient for countries around the world to adapt. So if you were able to produce some new technology that it would actually be cheaper to use than existing technology, other countries would not need all that much prodding in order to adapt it themselves. And so that's probably the best way to produce some type of change that stimulates a global adjustment in behavior. And then there's also just political leadership. I mean, the US is historically the largest emitter. They're still by far the largest emitter per capita. And they have kind of, even with the rise of China, uncompared political, economic, and diplomatic heft. And so if the US is kind of dragging their heels, it doesn't really inspire confidence in others, and it doesn't inspire others to really care about the problem at all because it feels like it's totally inevitable. But if the US were to change their actions, they would not only develop the credibility to stimulate changes in others, they would also kind of have more of, they would also have more of change that they just inspire kind of by the very active adjusting their emissions that inspire change. So those are ways to solve it. It's important to keep in mind what the current trajectory is. So the Paris Agreement that Trump withdrew from in 2017 and that Biden rejoined and kind of promised the U.S. to meet in this year is pretty effective, but it's not quite at the 2-degree level. If you can look, it's easy to track. Its current trajectory is just about at it's above kind of a 2-degree rise, although it's very, very close, which would kind of help with the case that we only need small or minor adjustments in order to hit an effective emissions target. It's not quite close to 1.5 degrees, and so if people read evidence saying that like that's the key threshold to avoid, you could be in trouble. But for the most part, the 2-degree threshold is a common one, and Paris is close to reaching it. That being said, it's, I think, a pretty weak case for U.S. emissions by themselves being sufficient to prevent any warming effect. If you look kind of at this graph, the U.S. has pledged to decrease emissions, and we can see the trajectory at which they're going to decrease by 2030. The EU is even lower. But neither India nor China have committed to absolute cuts, and based on their current pledges, the amount of emissions that China by itself will produce by 2030 is so monumental that it doesn't seem feasible that it would even come close to meaningful change. I mean, it's possible, but we'll see. You'd need probably a strong modeling claim or a strong U.S. key claim to make a very strong advantage for either. So that's like a basic survey of the background behind warming. I want to kind of get into the details of constructing environment in warming impacts. So I won't belabor the common sets of warming impacts that you've likely encountered before and that have already been discussed. Sea level rise, disease, natural disasters, sea level rise coming from melting glaciers that melt because the temperature is warmer. All of that seawater goes into the ocean. That ocean rises as a result and inundates coastal communities. That creates, as it's warmer, new vectors for disease spread. As all the climate rhythms are changing, it'll accelerate the pace of natural disasters. These will kind of converge. That's like the basic story for why warming is bad. I'm not going to lie, I kind of think adaptation arguments are actually pretty strong against this. And that's not just like saying like, oh, that's not going to kill everybody. Humans are resilient to extinction. I do think that too, which we'll get to in a second. But if you just think about kind of the past environmental changes, sea level rise, take that for example. The city of Amsterdam in the Netherlands is actually far below sea level. It's been below sea level since the 1600s. In an era where everything was built of wood and stone, they had no electricity, they were able to build dams and levees, which is what the modern Netherlands still rests upon. Given the massive advances in technology since then, it seems somewhat feasible that we can do the same if sea level rise happens around the world elsewhere. I mean, maybe some areas have a change in their agricultural pattern because some crops will now flourish in places they previously didn't. It's difficult to say exactly how or what the total civilization collapse storyline looks like. And then finally, tipping points is another argument that I just kind of don't love overall, because no one really knows when a tipping point's going to occur. No one knows what the tipping point is. They're all just kind of projections or guesses. It's easy enough to say we've already reached the tipping point, especially with like carbon emissions, which are already going to be in the air, and they're going to stay there for 250 years or more. And so if it's true that once you hit a tipping point, we just have this irreversible threshold, I don't know how effective the mitigation argument becomes against like the warming irreversible case defense. And then finally, I don't think that, especially when debating a broader swath of environment impacts than just warming, you should give up on defending the status quo. According to the Almanac of Environmental Trends, basically water quality, toxic chemical exposure, soil erosion, forest growth, wetlands, all of these are basically on positive trend lines right now, which is great news, although it does hurt advantage construction a little bit. And then kind of like as a separate rant about extinction, I've kind of made the case that warming may not be a civilizational collapse kind of event, but I don't even know if it's remotely close to extinction. And even if it was way worse, it probably wouldn't be. I mean, I do want to just kind of rant about this for a second, just because, for how reliant debaters are on extinction impacts, a lot of times we're very bad at debating them. We use bad impact evidence that's wildly overclaimed. And probably the easiest case mitigation you can get in an average debate is just pointing out that an impact does not have a warrant for extinction. And extinction is kind of worth focusing on, because if a team wins that, it's just a categorically distinct impact. It's irreversible. As far as we can tell, we are the only conscious, sentient, feeling beings in an incomprehensibly vast, dark, cold, and lifeless world. To make any value statement requires a human perspective and the potential of future human lives. And so do not spot their impact causes extinction, especially if you have one to compare of your own. Now, how do we know that extinction is tough? Well, I mean, in Indonesia, about 70,000 years ago, on the island of Sumatra, a supervolcanic eruption that definitely disrupted the human population. And we know this because only about 4,000 humans survived, like in the entire world. We're all descended from that population bottleneck of only 4,000 intrepid survivors. But this eruption was so big, it erupted 150 teragrams of black carbon. And if 95% of the nuclear weapons that existed on the planet at the height of the Cold War, and because of the Star Treaty, we don't even have that many, were emitted, that would only be 250 total. And if Stone Age hunter-gatherers could survive this type of massive event, it kind of suggests that far more technologically advanced humans would be likely to survive an extinction, what would otherwise be an extinction level event that's the most powerful we can think of, which would be nuclear winter. People on islands would probably survive. Low intensity agriculture means that even if there's no fossil fuels for fuel or fertilizer, you'd be all right. So it's tough to get to extinction generally, and that's with like a nuclear winter impact. With something that doesn't even have that nearly the type of firepower or kind of single event catalyst, it's even harder. Now, does that make it hopeless? No. I think there's a few different ways you could and probably should seek to construct ecological impacts. So by far the best, I think, is agriculture or food production for any environment impact, especially if you can control the U.S. environmental effects through U.S. action alone. And this is just because the U.S. is a global food exporter. We send out, mainly through trade on the open market, but also through just charitable aid as well, a lot of the food that we grow or livestock that we kill. And so if we can no longer produce such a surplus, it might cause food shortages around the world that would cause conflict. That's a pretty easy US key scenario that you can access just through solving environmental effects on food production. And that's tied to a lot of the core ways that water is going to be, water policy is going to be used on the topic. You can have local impacts, even if a lot of these are kind of silly. I mentioned the Yellowstone example earlier, maybe something like US-Mexico conflict over water scarcity, if you have some way to solve that, which there is some evidence about. CO2 and methane specific impacts are pretty useful, and I'll get to an example of those in a second. And then, of course, you can probably access this basic bigger impacts to warming if you have a modeling advantage. Although, for the most part, I think those are pretty weak unless you have some economic basis behind them, just because there's no impetus or reason that other countries would do something that's in their economic disinterest. Now, these are kind of dumb sometimes, and maybe I'm a little bit alone on this, but I do like some of the actual extinction warrants in these impacts. So, like, one of the classic runaway greenhouse effect claims is probably best found in this old book. There's kind of more recent evidence that says the same thing, but I just kind of love the language and phrasing here, which is that maybe a runaway greenhouse effect is responsible for what Venus is like now. I mean, Venus is an interesting case, right? It's another planet. It's about the same size as the Earth. It was caused by the same process as the Earth at around the same time. It's produced by the same materials. It has the same type of core. All the stuff, all the peripherals are about the same, and yet Venus is 800 degrees on the temperature. It's basically filled of, to the extent that it has oceans, its oceans are made of sulfuric acid, and it would kill anything that stepped foot there. And so why did Venus look like this? Or why does it look like this? Well, maybe it was just a greenhouse effect. And then as a result of that runaway effect, everything could die. And even after that effect eventually wears down, the Earth would actually look kind of the opposite, kind of like Mars with very, very thin atmosphere and nothing left. Now, a lot of people think that this runaway warming scenario is a little absurd, but at least this explains how or why you'd get to an extinction level event. Oxygen is another really common one, and this is not just for warming, but other impacts as well. And the basic argument here is that you lose the core material that most plants and animals need to breathe on the planet. And so if you decrease the levels of oxygen, it would disrupt the entire process. And this is also a little bit tied to the topic in the sense that most of the internal links to this say that if it's the oceans that keep warming, they'll become hot enough to stop phytoplankton producing oxygen, which is where most of the oxygen on the Earth comes from. And so that entire cycle will sort of cease to exist. And then another one that I find kind of funny is cognitive collapse, which is that if we keep raising carbon dioxide levels, basically human cognitive ability falls apart. We can't run our societies. There's also an external methane impact that I think could be kind of strong and that you'll see a lot this year, especially if an app just kind of solves methane. which is that as the air around the ocean warms, there's kind of similar to those ice cores in a way that we were talking about earlier. There's these ice-like structures at the bottom of seas that contain a ton of naturally occurring greenhouse gases, and there's 3,000 times as much time methane there as there is in the atmosphere. And a temperature increase of a few degrees could cause those to basically explode, and it would be way worse than a nuclear winter. It would be 10,000 times worse than all of the stockpile of nuclear weapons combined. So that's another way to kind of impact an actual extinction level event out. So hopefully that just helps with like thinking through how to construct these in a way that, you know, gets to a big terminal impact and makes sense with its solvency story. And I mean, you should be able to beat impacts and environment scenarios that don't meet those two criteria, like an impact that makes sense, solvency story that makes sense, basically on analytics or a few essential cards that you have in your back pocket to punish teams that don't strategize effectively. So we've talked a lot about warming. We're going to kind of go through a bunch of other environment impacts now because warming's important, but it's not everything. So biodiversity is oftentimes kind of like a catch-all for other environment impacts. Sometimes biodiversity impacts can be really, really bad. Like, you know, sea turtles are a keystone species for ecosystems. You know, the world depends on them. And that's not really an extinction impact. That's like barely anything. And there's so many people who say different things are keystone species that it's easy to read an alt cause to that and dismiss it. But you can impact out biodiversity similarly to other environment impacts in terms of agriculture or oxygen sometimes. And there are a few specific biodiversity impacts that are kind of useful. Honeybees, there's a lot of stuff about, especially because we kind of have a crisis in bees that is probably caused by fertilizer, which in turn probably could be regulated by the Clean Water Act or CAFOSAF. Albert Einstein had a quote that humans can only outlive the bee for 4 years. No more bees, no more pollination, no more plants, no more animals, no more man. It's the basic chain there. Coral reefs and deforestation both kind of are similar in that they produce a lot of oxygen and as a result act as sort of the lungs of the earth. So they can kind of hit that oxygen impact. And then there's even an internal link for insects as well that basically says industrialized farming would prevent the cycle of pollination and soil formation and soil aeration via its insect mortality rates. So biodiversity is common. I think it's probably a little bit weaker unless you have like a very good specific internal link that you can solve. And there are pretty good cards that say that biodiversity and warming are as important as one another, or maybe even that biodiversity is more important than warming. Warming's like overhyped in comparison. And so I wouldn't let the warming alt cause be a huge detractor from reading biodiversity. Kind of similar area is dead zones and hypoxia. Okay, so this is most common in the Gulf of Mexico. That's kind of most where it's discussed, but it definitely happens elsewhere. So the process of eutrophication is when a bunch of nutrients, frequently due to runoff that comes from the land, will cause a bunch of plants to grow and a bunch of animals to die because the plants steal all of their oxygen. Okay, so that oxygen lack is called hypoxia, which is just like whenever there's insufficient oxygen. And the subsequent water is a dead zone. And there's a very major one happening in the Gulf of Mexico right now due to the Mississippi River carrying all of this nitrogen-rich material, mainly fertilizer, from farms into the Gulf. So this is kind of like an essential topic, environment impact. You might be asking, could this hit extinction? Well, about 250 million years ago, the average oxygen level in oceans fell almost to zero, and that killed 95% of the world's species and the biggest mass extinction of all time. So there's definitely, you know, even if it sounds crazy, if these kind of cycles get out of control, one could maybe see a case for them occurring. Algae blooms are another route to oxygen loss, and this picture is from Lake Erie, where all of this kind of eerie green algae is taking over the lake. The process here is very similar, causes a bloom of algae and planktonic life that sucks all of the oxygen from the water. Usually algae blooms are freshwater kind of environments, and they'll be all green, whereas the saltwater will sometimes be green, but a lot of times it'll just kind of be like a lifeless, dull blue and look dead instead, and those are usually called dead zones. But they both kind of have the same hypoxic effect. Not amazing extinction impacts, but definitely bad, and definitely hurts maybe farming, certainly fishing, and so I think it's easy to write impact mods off of these. Endocrine disruption is an impact to any chemical emissions. These are basically the process of infertility-causing chemicals being released into the atmosphere. And there are some studies that say that humans will just literally become infertile and can't produce children, which will cause extinction for obvious reasons, as a result of these chemicals. And I think these are possibly regulated as well. If you have a modeling claim, you could probably solve it globally. A lot of studies debunk the initial studies as quoted here, especially as a lot of the studies that people cite this from are reliant on Finnish men who might have kind of alternative confounding variables that explain infertility. But there's like a surprising amount of data about this, and like you kind of see in the quote here, this is based on a meta-analysis of 185 studies. And so there's some scientific evidence for this type of impact, which I think you'll see with some frequency this year as well. Ozone is like basically one of the only good stories in recent environmental history. So if you'll look here, you'll see that ozone depleting substance consumption, which comes in large part, or at least came, through chlorofluorocarbons, or CFCs, which are like mainly found in cooling and air conditioning kind of systems, have actually decreased dramatically. And as a result, you can kind of look at the plotting here and see that the ozone in its average time per year is higher now, and this is from 2013, it was higher then than it was at any previous year from 1991 until then. And the reason ozone has actually kind of been making a comeback is because of the most successful environmental treaty, arguably of all time, the Montreal Protocol from 1987, in which 20 states agreed to ban or decrease substances responsible for ozone depletion. So the ozone is a layer in Earth's atmosphere that is above the stratosphere. It's made of a specific type of oxygen, O3, and it's essential in blocking UV radiation from passing through Earth's atmosphere. If it did, it would cause all kinds of harm to plants and animals, initially stuff like sunburn, skin cancer, and blindness, but eventually it would kind of probably be even more devastating. But we were able to regulate a lot of the problems with ozone out of existence, with ozone depletion out of existence, and that both bodes well for potential environmental solvency in the future, and it also is important to keep in mind in case you debate an ozone impact, because they do pop up from time to time, although a lot of times reliant on old evidence that doesn't take into account Montreal. Ocean acidification is another common impact, especially to carbon dioxide, and this is an impact to CO2 that's independent of warming. So if global emissions continue to rise based on current trend lines, the pH level of oceans is probably going to increase further, declining by about 0.15 units if carbon dioxide levels double. So the process here is spelled out in the graph. You have, with lower amounts of atmospheric CO2, a lot of the CO2 in the ocean is basically taken and used by coral reefs, by mollusks, and other calcifiers to build their shells. And that, as a result, is kind of an effective sink for carbon that prevents even more carbon from being left out in the atmosphere, and it initiates a bunch of life cycles for fish that rely on mollusks and coral reefs and plankton at the base of their food chains. And so if you get rid of all that stuff, not only are you going to have more carbon left in the atmosphere, which is especially important because like 90% of carbon in the ocean goes straight to the oceans. Like that's why 90% of heating in the oceans has been or 90% of heating has been in the oceans as opposed to elsewhere as the climate's been warming. And you can basically solve some of the worst warming by having all of that carbon calcified, as well as keeping the fishing ecosystems healthy. The best impact to that is probably just fisheries type stuff. But this is very common as well. And so like, this is useful to keep in mind because let's say a team reads a counterplan that solves warming, which we'll get to in a little bit. CO2 impacts independent of those, like ocean acidification, would not be solved. Like even if they were able to keep temperatures high, if they don't actually solve CO2 emissions, you're able to be like, that will kill an ocean environment that's crucial to commercial fisheries and ecosystem growth underseas. So this will be another, I think, common impact to warming and CO2 this year as well. Phosphorus is another agriculture impact. So phosphorus is a key nutrient. It's in our DNA. You need it for life itself. Fertilizer is, the synthetic fertilizers that are usually nitrogen dependent and are sprinkled over farms in order to help crops grow and kill pests that would otherwise eat or ruin the crops. Fertilizer is very phosphorus intensive, and it actually uses a lot of the organic phosphorus found around the planet. And some people think that phosphorus sources are basically fixed, and we're at the risk of bypassing peak phosphorus, where we use half of all the phosphorus in the world, and there'll be huge shortages and violent tensions as a result of that. And so minimizing the nitrogen fertilizers that deplete phosphorus would be important as a result. There are decent answers to this, but you'll see phosphorus pop up a lot as well. And if you don't have a specific card about phosphorus to answer it, it could kind of appear as fairly external. Okay, so we're going to go over a few other environment arguments, kind of just impact turns and counterplans that are useful to keep in your back pocket and keep in mind while constructing these for the final part of this lecture. Okay, so impact turns are definitely omnipresent in the environment debate. Biodiversity bad is definitely a possibility. So an easy way to set up biodiversity bad is a lot of the environmental conduits you've seen in the past few slides were all about oxygen levels, right? We need to make oxygen levels higher, prevent them from getting too low. Well, I mean, oxygen is the catalyst in the air that allows fire to happen. And so if we actually increase oxygen levels and prevented them from decreasing, and perhaps forest fires would be more likely, which could have catastrophic outcomes. There are some people who say algae blooms are actually very, very useful because we can take all that algae and use it to create artificial fertilizers that aren't nitrogen dependent. And so we can sort of like solve the phosphorus problem, or we can solve other problems with fertilizer and make agriculture more sustainable if we use algae. There's other biodiversity bad impact turns, and I think our lab's going to put out a couple of these in a file. there's some evidence that says that just like keeping a whole bunch of different species around makes it easier to learn how to do biopiracy, which would cause gene editing and designer babies and all this bad stuff. And separately, when we intervene in nature to prevent species that are weak and maladaptive, that like kind of don't have the evolutionary advantage to survive, and protect them, it has second order effects that disrupt the rest of the food chain down the line. And that's bad and kind of has worse ecosystem restoration problems later down the road. These aren't all that good, but you need to have blocks to them if you're reading any of these advantages. Warming good is kind of classic, and Forsland covered some of these in his lecture as well. He covered especially SO2 screw and ice age, which are both kind of bad. The SO2 screw is just that one of the greenhouse gases that if you decrease all of greenhouse gases, you'd also reduce is sulfur dioxide. And sulfur dioxide has kind of a cooling effect because it actually blocks sunlight from hitting the earth more so than it traps it here. And so because of that, it cools the earth a little bit. The problem is it doesn't have nearly the effect of carbon. Like you'd have to kind of win warming not happening now / global cooling now in order to set up uniqueness for the SO2 screw, which is why it's pretty ineffective. But the SO2 screw goes, because you stop all of this stuff from being put into the atmosphere, you actually stop sunlight from being blocked by the sulfur dioxide. We need more sulfur dioxide. And like I said, it's rough because if that was true, then we'd have global cooling now. And if it wasn't, then because we have what we have now, then it doesn't follow that more SO2 would counteract more SO2 that goes along with it. Ice age has a similar problem as like one of the worst arguments, which is that there's going to be an ice age coming now, and warming's actually great because it prevents it, and it has the similar uniqueness problem that we expect cooling if there's going to be an ice age. Okay, CO2 ag is better in that there's a core argument here, which is that for certain plants, and there's kind of a big division in agricultural plants. You have C3 plants and C4 plants. In C3 plants, which includes like some pretty important crops like rice and wheat, the more carbon, the merrier, basically. And you can grow more of it more effectively if there's more carbon in the air. And that's key to increased food production, which prevents famine, food wars, and kind of gets at the agriculture impacts that are one of the best impacts to climate. Okay, so that's like an argument. The problem is, so from the outset, it actually really hurts other plants, like C4 plants, like maize, soybeans, and a few others. So a lot of plants actually get destroyed by this. A lot of C3 plants are actually weeds, so stuff that you don't want alongside your crops. And if there's more of that, they'll actually outcompete the crops and cause the weeds to proliferate and overrun the effects. And finally, the effects of warming on crops are typically pretty bad as well, especially given that the specific ways crops are grown in different areas of the world are very, very tailored to the precise climatic conditions. And so across the board, it doesn't really follow that net effects on crops would be very good. But this is definitely, of those arguments, the one that you should look into the most and kind of learn about, because there is something there, even if admittedly a lot of the proponents of this argument, not every proponent, but many of them, are likely kind of dishonest brokers who are funded in part by the fossil fuel industry. Okay, so in my opinion, and this one has not been very highly explored, especially in recent years, despite it getting better by the year, I think the best warming good impact turns probably would relate to geopolitics. I mean, there's a New York Times article that came out about this last year. If you just Google Russia warming New York Times or Russia wants global warming New York Times. But basically, for countries that are very, very far north, global warming could be a boon economically, especially based on the agricultural capacity that it promises. It'll also be a boon for mining and energy, as it'll melt the ice caps that block a bunch of minerals from being extracted in the polar regions of the globe. And so if you had like a Russia power good, Russia, like China basically China-Russia war or China-Russia border war inevitable due to population tensions. Only Russian power can fight that back is like one easy scenario to write. And then the basic just Russian economy collapsing now, warming key to Russia. And there is even stuff that says that warming would be net good for the U.S. geopolitically, that one of its advantages over China in the coming century and the competing kind of geopolitical landscape would be its location. It's farther north, and so China is going to be far more hurt by warming, which, among other things, is disproportionately likely to affect countries by the tropics. And so that could be a helpful thing geopolitically. It's obviously pretty cruel as an argument because it would just spot a bunch of harms happening to countries that are disproportionately poor around the equator. But that's definitely a way to write warming good arguments that I think avoids a lot of the science behind, like the bad science behind, say, SO2 or Ice Age, if you were so inclined. So just some advantage counterplans to keep in mind to definitely write and have ready to go. So for biodiversity, both building artificial coral reefs, which the U.S. actually has already jump-started by something called a Rigged Reef Program, but probably needs to get bigger if it's going to actually protect a wide swath of biodiversity, and via gene banks, which just store a bunch of genetic information, which can be used for like future cloning or the future creation of like resurrection of new ecosystems or animals that go extinct, I guess like little Jurassic Park style. Those are two ways to, I think, solve ecosystem restoration and management that at least solve the terminal impacts for some of those core biodiversity claims. There's even like artificial bees, artificial pollination to solve honeybee type stuff. So I would have those ready to go and some answers to them for, saying that they're insufficient if you read anything relevant to, if those were relevant to an advantage for your F. Another common one will be food production counterplans. And remember that the easiest way to impact out solving some local problem in the U.S. Environmentally is going to be via its impact on agriculture. And so you can just spot them that agriculture would get worse given their problem and have an alternative way to increase food production. The easiest way is probably artificial meat or ending agricultural subsidies for big farms and kind of having a general defense of industrial agriculture, which a lot of people say is, for example, there's a time profile about Nathan Borlaug as the greatest humanitarian in global history that nobody knows, because basically this guy just figured out how to use fertilizer to more effectively synthesize wheat in both India and in Mexico. And his wheat strains probably cause billions of people in Latin America and South Asia to get fed that otherwise wouldn't have, which prevented famine and a lot of problems. So kind of fertilizer is good, is in existence, and like there's no alternative to nitrogen fertilizer, stuff like that is going to be useful to have. And then finally, the most important warming advantage counterplan is geoengineering. And so there's two basic sets of geoengineering proposals. So geoengineering just seeks to directly change the temperature of the climate through intervening in it. So one type solves carbon via sequestering it, which just means taking it out of the atmosphere and putting it into something else. You can build millions of artificial trees. You can find reservoirs either in oceans or in basically just like giant plant reserves right outside of coal plants that take most of the emissions from power facilities and store that carbon instead of letting it seep into the atmosphere. And basically any way to take carbon out of the atmosphere and store it in either a natural or an artificial reservoir so that it doesn't go into the atmosphere would be sequestration. And that would solve the kind of CO2 specific impacts as well. But another form is solar radiation management, which is basically just manipulating sunlight to change the temperature. And if you're going to go for CO2 ag, this is probably what you want to read alongside it, because this would not solve CO2, but it would solve the impacts of high temperatures. So there's a few different ways you can do it. You can put giant mirrors called sunshades in space. you could release a bunch of chemicals and gases that seed clouds, probably into the stratosphere, the layer of atmosphere right above the troposphere where we are, or in maybe one of the best vetted proposals for this overall, you could put billions of latex or plastic bubbles. There's proposals for either that are usually biodegradable or at least not toxic because they're literally so small that they don't. They're like not going to cause major fish population decreases, and they wouldn't interfere with like algae or anything. So either latex or microplastic, and billions of them all over, and that reflects sunlight. And the way all these work is they just make the Earth a little bit brighter or a little bit more reflective of sunlight, and so the sunlight will go back into space and not stay and be trapped here. And so that's the basic process for geoengineering. Now, when you're answering this, obviously the gold standard for an answer is going to be something very specific. That's like, your proposal is infeasible, it doesn't work, it causes problems. But there's a lot of these different proposals, and there's more of them by the day. And so the best general answer is typically about international backlash, which makes sense because it follows that one country dictating global climate will probably not be received fairly by the rest of the world, especially because different countries have different climate goals. So like Russia probably wants the world to get hotter, and they'll be very mad at something like this. And so you could see wars even over something like this emerging. I would say if you're running geoengineering against like a serious warming advantage and you want to win, there's probably two things to do. First, against all that stuff, you should say geoengineering is inevitable. But also, you should probably try to establish an international treaty for your geoengineering system that mitigates the international backlash to it, or else it's going to be susceptible to that type of unilateral control bad argument. Okay, and so that does it for the lecture this morning. I hit my goal of about an hour, and I really did want to just give a survey for the core argument types and profiles to expect on this topic, and kind of hit those core themes of thinking about how to construct coherent solvency and terminal impact modules for environment impacts. This is going to be a huge swath of the topic, like 50% plus probably. So you're going to be seeing these themes a lot, and they'll be explored in greater depth throughout the rest of camp and this entire year. And so I look forward to any questions and hope that was informative. Thanks, and have a good evening, or have a good afternoon and evening while I'm recording this.